Welcome everyone. For today's prep, we're going to be looking at constrained optimization. And we're going to just look at an example to see what types of problems these kind of look like. And our first example, and the one example we're going to be looking at right now, is, well, let's read through it. So we want to find the max value of this function q, which is equal to x times y, provided 2x plus y is equal to 4. So a problem like this is called a constrained optimization. And the way we're going to solve these types of problems, the first step is to figure out what the objective function is and what the constraint equation is. All right, so first of all, what do we mean by objective? Well, this is whatever we want to maximize or minimize. So if we go back up to the wording of the problem, we want to find the max value of this function q. So this is going to be our objective. So we'll call this equation our objective function. Now the constraint equation, what's the constraint equation? Well, this is some equation, or maybe even other conditions, that put some restriction on our variables. So if we go up to our optimization or our objective function, the variables here are x and y. And if we wanted to make this function as big as possible, well, then just make x and y as big as possible. Except we can't, because we have this other equation, 2x plus y is equal to 4, that puts some limitation on what x and y can be. We can't just use any x and y. We can only use the x's and y's that satisfy this equation. So when we take our x and multiply it by 2 and then add in y, we should get 4. So this puts some restriction on what x and y can be. And so this is going to be our constraint. All right, so the first part of these problems is to figure out your objective and your constraint. So then the second step will be to kind of work with this constraint equation, and we're going to solve it for one of the variables. And you have a choice. So usually you pick whichever variable is easier to solve for. So in our case, y is a little bit easier to solve for because all we have to do is subtract 2x from both sides. So we're going to take our constraint, the 2x plus y is equal to 4, and we're just going to solve that. And when we solve that equation for y, we're going to get y is equal to 4 minus 2x. So we just take our constraint and we solve it for one of the variables. Sometimes you might solve for x. In this case, we're solving for y. All right, so what are we going to do with that? Well, we're going to take that result, and in our third step, we're going to plug that into our objective. So wherever I see a y, in this case, in my objective, I'm going to replace that with what we just found. This y is equal to 4 minus 2x. And this is kind of where we want to go. So when we replace that, we replace that y with 4 minus 2x. And now what we have, this is a one variable function. And that's what we want, a one variable function to optimize, because all of our max and min techniques that we figured out all involve doing the first derivative and then figuring out the critical numbers and going on from there. But we need a one variable function in order to do those things. So that's what we need. So we know we're going to do the derivative. So to help us out, let's multiply this thing through. So we get 4x minus 2x squared. That'll just make doing the derivative a little bit easier. And now in this fourth step, we're going to optimize this function. And that means find and then classify the critical numbers. So we break this step into two parts. First part, we're going to find our critical numbers. And then the second step, we're going to classify them. And we know we have kind of two different tests that we can use. So first of all, let's find them. And to do that, we need our first derivative. So we're going to calculate q prime, differentiate the function here. we get 4 minus 4x. And then there's two ways we can get a critical number, either from where our derivative is equal to 0 or where our derivative does not exist. And if we look at our derivative, there's no division by x, so there's no division by 0. There's no negative exponents, which kind of hide that. So we're not going to get any critical numbers this way. But if we take our first derivative, set it equal to 0, if we solve that, we get x equal to 1. All right, so that is our critical number. We got one critical number here. So now we want to classify it. And how do we classify? Well, we have two options, first derivative test or second derivative test. So we could do either one. Usually second derivative test is a little bit quicker, so we'll try that one. Sometimes this can be inconclusive, but not usually. So we'll try our second derivative test. So whichever test you do, you go with, state the name of the test you're going to use. So we're going to use the second derivative test. And as the name suggests, in order to do that, we need our second derivative. So our second derivative here, if we go over and differentiate our first derivative, we just get -4. And how the second derivative test works is we take the critical number that we want to classify, and then we plug it into our second derivative. We evaluate our second derivative, in this case at x equals 1. And for this second derivative, the second derivative is constant, so no matter what x value you plug in, you're always going to get -4 out. So the value here is going to be -4. And then we just have to interpret that. So negative second derivative means concave down. Draw the concave down shape. And what do we have? Local max. Okay, so we're just about done. We found the critical number. We know we're having a max there. So we just want to make sure in the last step that we actually answer the question. So it might sound obvious, but you just want to make sure you're actually figuring out what the question is asking you to figure out. So if we go back, what did we want to find? We wanted to find the max value of this function. So we found where the max happens. That's what this x equals 1 is. And we know that we do indeed have a maximum. So to get the max value, we're going to evaluate the function. So we want the max value of q. So what that means is evaluate our function q. So we got to evaluate it. That kind of looks like in our function q. All right, so we have kind of two versions of function q. We have our one variable version here, which that's the one we're going to go with. But we could also figure out what y is, plug our x value in here, figure out y, and then we could just go back to the original source, x times y for our q. But better to just kind of use this one variable version because we already know what x is. So if we plug in there, we're going to plug 1 in wherever we see an x. So we get 4 times 1 minus 2 times 1 squared, which, if we simplify, is 2. And that's our answer. So we wanted the max value of our function, and we found it. And we know it happens, we know where it happens at x equals 1, but we actually wanted the max value. So you just make sure for that last step, you're actually reading the question. Sometimes the question will say, find the max value of your function or the min value of your function, or the question might ask, find the x and y values that give you the maximum. So depending, you might be finding different things. All right, so we'll stop there for today. We'll try a few more of these in class. So we'll see you then. Bye-bye.